Welcome to the comprehensive demo video on the basic implementation of the Open Charge Point Protocol, or OCPP version 2.01. In this video, we will walk you through the key functionalities and features of OCPP, showcasing how it enables seamless communication and control within the electric vehicle charging infrastructure. We will cover the process of booting a charging station, configuring its settings, resetting it when necessary, and demonstrating various authorization and transaction mechanisms, etc. Join us as we explore the fundamental aspects of implementing OCPP, providing you with a practical understanding of this powerful protocol. Let's dive into the demo showing our work. Now, we'll explore the use case of booting a charging station. Let's walk through the scenario. Step 1. The charging station powers up and open connection with CSMS. Step 2. The charging station sends a boot notification request to the CSMS. Step 3. The CSMS responds with a boot notification response. Step 4. The charging station sends a status notification request to the SIEMs for each connector. Step 5. The charging station is now registered to the CSMS, and the charging station sends heartbeat periodically. Now, we will cover charging sessions use cases. Step 1. The vehicle driver enters PIN code. Step 2. The vehicle driver is authorized by the CSMS. Step 3. The vehicle driver attempts to lock the connector not locked properly. Step 4. The charging station generates a notify event request to notify CSMS about the problem and prevents the driver from starting a charging session until the lock failure is resolved. Once the lock failure is resolved and the connector is properly locked, the vehicle driver can proceed with starting the charging session. Finally, when the cable unplugged, the total cost of the session will be showed on the screen. Next, we will discuss the use case of set variables request in a charging station. Step 1. CSO triggers the CSMS to request the modification of one or more variables in a charging station. Step 2. The CSMS sends a set variables request to the charging station, specifying the variables and their desired values. On its side, the charging station responds with a set variables response, indicating whether it successfully executed the requested changes. In our example, there are two variables, one is read-only and the other is read-write, which so one is accepted and the other is rejected, as we see in the logger. Now, we will explore switch availability use case. Sometimes the station needed to close a connector for maintenance or other purpose, and that is provided just by a button click, which switch from available to unavailable and vice versa, in case there is no going charging sessions. Now, we will cover the use case alert event. If a threshold value has been exceeded, the charging station sends a notify event request to the CSMS. We are simulating this scenario by this slide bar that represents the sensor in a real charging station. Exceeding the lower or the upper threshold gives an alert to the CSMS eventually. We will explore how the CSMS can request a charging station to reset itself. Let's dive into the scenario and follow the steps involved. Step 1. The CSO requests the CSA requests the CSMS to reset the charging station. Step 2. The CSMS sends a reset request to the charging station, specifying the need for a reset. Upon receiving the reset request, the CSMS takes action by sending a reset request message to the charging station. This message includes the necessary information to request the charging station to reset itself. The CSMS can indicate whether an on-idle or immediate reset is required. On the charging station side, it will reset itself and send a boot notification request to the CSMS in case there is no active transactions. Thanks for watching.